Hello friends, welcome to my channel. Let's have a look at problem 2583, Kth Largest Sum in a binary tree. In this video, we are going to share a solution based on level order traversal plus sorting. First, I will read through the problem statement, and then we do the analysis, and finally, we share two formats of codings. First, let's look at the problem statement. We are given the root of a binary tree and a positive integer k. The level sum in the tree is the sum of the values of the nodes that are in the same level. So we are required to return the kth largest level sum in the tree. If there are fewer than k levels in the tree, we're going to return -1. So here there's a node which says that two nodes are on the same level if they have the same distances from the root. So here are two examples, and example 2 is for the output that is 3. So k equals 1 because it requires the largest level sum, that is 3 right here. So for the first example, the level sums are 5, 17, and 13, 10, right? So the second largest one is 13. So before we do the analysis, let's also look at the constraints. First, the number of nodes in the tree is n, and n is bounded below by 2 and bounded above by 10 to the power 5. And the node values are in the range 1 and 10 to the power 6, and k is in between 1 and n, right? So the last one is basically a consistency assumption. So with that said, we are ready to look at the analysis. So here, as we mentioned at the very beginning, so our treatment will be based on level order traversal plus sorting. So the core ingredient for this problem is level order traversal. So for the level order traversal, we will use list comprehension here. And well, for the sorting part, we could provide two formats. The first format, that is option 1, so we can just collect all the level sums and then sort and then get the kth largest level sum if possible. Option 2 is that we're going to use a min heap to directly get the kth largest level sums if we can, and then we return the smallest among them. So this is our overall plan, right? We will provide two formats of solutions based on the variance in the sorting stage. So here the return is the following. If we can collect k level sums, we are going to return whatever the kth largest level sum. Otherwise, we shall return -1. Therefore, we need a condition check here. So here is a walkthrough for example 1. So we can get the level sums. So here there are 4 levels, right? 5, 17, and 13 and 10. So let's delete this this one. Let's see, level 1, level 2, level 3. So the second largest is 13, right? So let's delete this one. We write one more, 13. So with that said, we are ready to do the coding part. So in the first format, I'm going to write with a brute force sorting. So let me make some annotations here. So here we are going to use level order traversal plus a sorting. So this basically is very easy to coding. So we're going to let the level sums to be empty list, and then we do level order traversal to get the level sums. So container, so let's go to the root. So here we can directly do this without edge cases check because the tree is not a null tree by assumption. And then what we're going to do is the standard while loop, right? So then what we're going to do first, let's use a comprehension to get the level order sum. So you can regard this as a iterator. So node value for node in container, the current state of container. So this S will give us the level order sum. So here I introduce this variable just for clarity. And then what we're going to do is level sums append this S, right? And next, what we want to do is to update the container state. Here we use list compression again. So here we get child for node in container, for child in node left and node right. We just collect all the null ones if child. So this way we updated the container state. So after this while loop, so we are going to collect all the level sums available. And then what we are going to do is to do the sort. We can sort in place. So this way, if we do not pass some argument, this is sort from small to large. So let's keep this sorting order. Then what we are going to return is level sums. So negative key. If the length of this level sums is greater, so it's greater than or equal to k, right? Otherwise, so we just return -1. So this is the one format of solution. But in between, each time if you do an append operation, you can use a counter to increment that counter by 1. Then afterwards, you do not need to call the length method. But this will be okay because we just call once. So with that said, let's first do a check. It passes the first example, I guess. Now let's look at the generic case. Yeah, it passes all the generic cases fast. So with that said, let's also write another solution format. So here, because the k might be small, but the number of levels might be very large. So here we use a lot of extra space. That's the possibility. So we're going to copy this part and then change this one to be v1, right? So this is one solution. So now let's look at the second version. So here I'm going to use level order traversal plus min heap. So basically, we want to keep this level sums. So this is a list. Let me also copy this part. So let's make some modifications. So here we get S. After we get S, what we are going to do is like this. So let me also introduce a number of elements in this list or heap. So what we are going to do is we call this module heap q, heap push. So we are going to push level sums to this heap, right? And then once we do the heap, so push operation, we increment number of elements by 1. So now we want to check if n elements is greater than k, right? If this is the case, so we are going to do a pop operation. This is heap q, heap pop, right? Pop level sums. So this way, the number of elements in this heap is always kept above by k, right? So then we update the container state. So after this while loop, so we do not need to sort anymore. Then what we are going to do is to return level sums 0. The reason we return level sum 0 is that this current state of level sum, this variable is actually representing a min heap. So the 0th element will be the smallest, right? So we find the smallest one if n elements equals k. Otherwise, so we're going to return -1. So this is in essence the same as the first version. However, due to the introduce of the variable n elements and due to the use of min heap, there is a possibility to save some space. So with that said, let's also do a check. So here else, so here it is not if, so here is return. So now let's check this. Let's see, n elements equals k. Let's see where's the problem. Here n elements, heap levels, n elements. Oh, sorry, here. So when we do the pop, we need to decrement these elements by 1, right? Don't forget this operation. So let's check again. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases fast. So I guess that's about it for the solution to this specific problem. So here the ingredients for this solution are level order traversal and sorting, but the main part I feel is still level order traversal. But for treating the sorting part, so we can use a verbose sort, or we can use min heap to save some potential space. So with that said, I guess that's about it for this problem and this video. You're welcome to check out other videos in my channel for more problem analysis. That's it. Thank you.